In 2022, the James Webb Space Telescope pointed its golden eye at the early universe and found something nobody expected. Small, mysterious red objects. They called them little red dots. And for the last 4 years, these tiny specks of light have been one of the biggest mysteries in modern astronomy. Some scientists even said they broke cosmology. But now, thanks to a tiny dot named Glimpse 17775, we finally have the strongest evidence yet for what these objects really are. This is the story of black hole stars. Let me start with a quick refresher. When James Webb launched on Christmas Day 2021, astronomers had a pretty good idea of what the early universe should look like. They had models. They had simulations. They had decades of theory predicting how the first galaxies formed. The universe, they thought, built itself up gradually. Small galaxies merged into bigger ones. Stars formed steadily over hundreds of millions of years. Nice and orderly. But Webb's first deep field images immediately shattered those expectations. Among the thousands of distant galaxies, astronomers spotted something strange. Small, compact objects that appeared incredibly bright for their size. And they were red. Really red. So red that they became known simply as little red dots. Here's what makes little red dots so puzzling. They appeared in large numbers around 600 million years after the Big Bang. That's incredibly early in cosmic terms. If the universe was a person, these objects appeared when it was just a toddler. And yet, they were shining with the light of what should have been impossibly massive galaxies. The problem was simple arithmetic. If those red dots were galaxies full of stars, then those galaxies would have had to form billions of stars incredibly quickly. Faster than any model predicted. Faster than seemed physically possible. That's why some scientists said Webb had broken cosmology. If these objects were what they seemed, then our entire understanding of how the universe built its first galaxies was wrong. But there was another explanation. What if the light from those little red dots wasn't coming from stars at all? What if it was coming from something else? Something much more violent. Enter the black hole star theory. The idea goes like this. What if little red dots aren't galaxies at all? What if they're supermassive black holes caught in the middle of an intense feeding frenzy? As the black hole devours surrounding gas and dust, the material heats up to millions of degrees and blazes with light. But here's the key. All of this is happening inside a dense cocoon of gas. Like a dragon hidden inside a cloud of smoke, the black hole's true nature is obscured. The name black hole star is actually a play on words. In one sense, it describes a black hole that shines as brightly as a star. But it also refers to a real theoretical object from early universe cosmology, where a star-like object was powered by a black hole at its center. For years, this was just a theory. A compelling one, but without direct evidence. Astronomers needed to catch one of these little red dots in the act. And that's exactly what happened with Glimpse 17775. Glimpse 17775 is a little red dot located behind a massive galaxy cluster called JWST 1063. And it was incredibly lucky for science that this particular dot ended up in just the right place. You see, the galaxy cluster JWST 1063 is so massive that its gravity bends the fabric of space itself. This creates a natural magnifying glass effect called gravitational lensing. Light from background objects gets stretched and amplified as it passes through the warped space around the cluster. For Glimpse 17775, this gravitational lensing gave it a huge boost, effectively turning 30 hours of Webb observing time into the equivalent of 80 hours. With that incredible data, astronomer Vasily Kokorev from the University of Texas at Austin and his team went to work. They obtained the deepest spectrum ever captured of a little red dot. And what they found was extraordinary. A spectrum is like a cosmic fingerprint. Every element and molecule leaves its signature in the light, a pattern of bright and dark lines that tells scientists exactly what the object is made of. Glimpse 17,775 spectrum contained over 40 distinct spectral lines. That's more than any other little red dot ever studied. And it included something the team called an iron forest. 16 separate iron lines, each one telling a story about what was happening inside this object. Here's what those 40 lines revealed. First, the hydrogen, oxygen, and helium lines didn't fit a simple model of a rotating gas cloud. The lines were too broad, too spread out. The only way to explain that broadening was through something called electron scattering. In simple terms, light was bouncing off free electrons inside a dense, layered gas cocoon. Exactly what you'd expect from a black hole star. Second, the strength of those 16 iron lines required an enormous energy source. Not a star or a group of stars, but something much more powerful. A rapidly accreting supermassive black hole was the only explanation that fit. Third, the team found both fluorescence and absorption of helium in the same spectrum. That combination is a smoking gun. It independently confirms that a dense medium is surrounding a powerful central engine. And here's the really elegant part. This same dense gas cocoon explains why most little red dots are completely invisible in X-ray surveys. If a black hole was feeding in open space, its X-ray emission would be detectable across the universe. But the cocoon absorbs those X-rays, making the black hole appear dark in X-ray light while still blazing in optical and infrared. It all fits together perfectly. But there was one piece of the puzzle that seemed to be missing. Little red dots typically have something called a Balmer break, a sharp dip in their spectrum caused by hydrogen absorption. Glimpse 17,775's Balmer break was weaker than expected. For a moment, this seemed like it might contradict the black hole star model. The team turned to NASA's Hubble Space Telescope for help. Using data from two programs called Frontier Fields and Buffalo, they discovered the missing piece. Glimpse 17775 is surrounded by a giant host galaxy. That host galaxy contributes extra blue light, filling in the Balmer break and explaining why it appears weaker. This is the first time anyone has clearly detected the host galaxy of a little red dot. Think about what this means. Not only does Glimpse 17775 have a feeding supermassive black hole at its center, it also has a massive galaxy wrapped around it. An entire cosmic ecosystem, hidden inside a little red dot that appeared as nothing more than a faint smudge of light. Vasily Kokorev put it beautifully. He said, "When we saw the spectrum for the first time, it was like having all the pieces of a puzzle scattered on the floor. We picked up each piece, measured the lines, and started combining them into a mosaic. Everything fits. Nothing is broken. And that makes the puzzle that is our universe even better." This discovery has profound implications for cosmology. Remember how some people said little red dots broke cosmology? This discovery puts that concern to rest. The black hole star model does not require impossibly massive galaxies to exist in the early universe. The intense light from these objects is coming from black holes, not stars. The standard model of cosmology is safe. But this also raises even bigger questions. If little red dots are supermassive black holes, how did they get so big so fast? The current record holders are black holes found just 500 to 700 million years after the Big Bang, with masses of billions of suns. That's hard to explain with normal black hole growth. One possibility is direct collapse. Instead of forming from a dead star, some black holes might have formed directly from enormous clouds of gas collapsing under their own gravity. These primordial seeds could have started at 10,000 or even 100,000 solar masses, giving them a huge head start. Another possibility is super-Eddington accretion. Normally, black holes have a limit on how fast they can eat. This is called the Eddington limit. But recent research suggests that some black holes might temporarily exceed this limit, gorging themselves at extreme rates. Like a cosmic Thanksgiving dinner that lasts 1,000,000 years. Glimpse 17775 exists at a redshift of 3.5, meaning we're seeing it as it was about 1.8 billion years after the Big Bang. That's in the middle of the little red dot era, when these objects were abundant but starting to disappear. By about 2 billion years after the Big Bang, most little red dots have vanished. According to the black hole star model, that's because the feeding frenzy ends. The black hole either clears away its gas cocoon, revealing itself as a normal quasar, or it runs out of fuel and goes dormant. The discovery also showcases the incredible power of combining multiple telescopes. Webb provided the deep infrared spectrum. Hubble provided the optical data that revealed the host galaxy. And gravitational lensing, provided by nature itself, gave them the magnification they needed to see this tiny dot in exquisite detail. Astronomy is increasingly a collaborative effort between instruments, between space agencies, and between scientists around the world. Looking ahead, Kokorev and his team plan to investigate what powers the central engines of more little red dots. They want to know if all little red dots are black hole stars, or if different objects have different explanations. Maybe in a year or two, we will have the final answer. This is what makes astronomy so exciting. Every time we build a more powerful telescope, we discover things we never imagined. When Hubble launched, it showed us the age of the universe and the existence of dark energy. When Kepler launched, it showed us that planets are everywhere. Now Webb is showing us that the early universe was far more violent and dramatic than we ever expected. In the end, the story of little red dots is a story about human curiosity. About our determination to understand the universe we live in. About our refusal to accept mysteries at face value. For years ago, little red dots were an enigma. Today, thanks to glimpse 17775, we have our strongest evidence yet that these objects are black hole stars. Supermassive black holes, hidden inside cocoons of gas, blazing across the early universe. There is still much to learn. Kokorev himself says that while a black hole is the leading theory, there are other interesting proposals being explored. The scientific process is never truly finished. Each answer leads to more questions. That is not a weakness of science. It is its greatest strength. So the next time you look up at the night sky, remember that the universe is full of hidden wonders. Tiny red dots that hold the secrets of cosmic evolution. Black holes living inside cocoons of their own making. Ancient light that traveled for billions of years to reach our telescopes. And with each new discovery, we come one step closer to understanding our place in this vast, beautiful, and endlessly surprising cosmos. If you enjoyed this video and want to explore more mysteries of the universe, make sure to hit that subscribe button and turn on the notification bell. I release new videos every week covering the latest discoveries in space and astronomy. From the James Webb Space Telescope to black holes to the search for life beyond Earth, we cover it all. Thanks for watching, and I'll see you in the next one.